The National Electrical Code, or NEC, requires that all electrical connections be accessible for inspection and maintenance. There is an exception, however, for low-voltage wiring operating under 50 volts that is not exposed to moisture or physical damage. Doorbell transformers typically operate at low voltages, usually between 16 and 24 volts alternating current, and are generally not exposed to moisture or physical damage when located in a ceiling. Therefore, splicing the low-voltage 18 American wire gauge or wires and leaving them in the ceiling is acceptable according to the NEC under these conditions. Here are some recommendations to ensure a safe and reliable installation. Firstly, use wire nuts to make clean and secure splices. Wire nuts are designed to create a tight, insulated connection between two or more wires. Ensure that the wire nut is properly sized for the number and gauge of the wires you are connecting. Twist the wires together tightly before screwing on the wire nut. This will help to ensure a good electrical connection. Secondly, protect the splices from movement or damage. You can protect the splices by taping them with electrical tape or by placing them in a junction box. Electrical tape will help to insulate the splices and prevent them from shorting out. A junction box will provide additional physical protection for the splices. Thirdly, leave a small loop of wire for future access if needed. This will make it easier to access the splices if you need to make any changes or repairs in the future. The loop should be long enough to allow you to comfortably work on the splices without having to cut the wires. Here are some more detailed points regarding splicing low-voltage wires behind drywall. The NEC addresses the general requirements for electrical connections in Article 110.14 covering electrical connections, which states that splices and connections shall be mechanically and electrically sound, and made in a way that ensures good contact between the conductors. It also stipulates that the connection should be approved for the purpose. However, the key here is understanding the exceptions granted for low-voltage systems. Chapter 3 of the NEC covers wiring methods and materials. While it provides detailed rules for higher voltage circuits, it offers more leeway for low-voltage applications. Specifically, NEC Article 725 addresses Class 2 and Class 3 remote control, signaling and power-limited circuits, which often include doorbell circuits. These circuits are considered low energy and are therefore subject to less stringent requirements. These are the key points to remember. Firstly, voltage limitation. The NEC generally considers circuits under 50 volts to be low voltage. Doorbell transformers typically output 16 to 24 volts alternating current, falling well within this limit. Secondly, power limitation. Class 2 and Class 3 circuits are not only voltage limited but also power limited. This means that the amount of energy they can deliver is restricted, reducing the risk of electrical shock and fire. Thirdly, acceptable conditions for inaccessible splices. While the NEC generally prefers accessible connections, it recognizes that low-voltage circuits pose a lower risk. Therefore, splices for Class 2 and Class 3 circuits can be concealed without a junction box, provided they meet certain conditions, such as being mechanically sound and properly insulated. Here is a look at how to make a proper splice. Firstly, strip the wires. Use a wire stripper to carefully remove about half an inch of insulation from the ends of the wires to be spliced. Be careful not to nick or damage the conductors. Secondly, twist the wires together. Hold the stripped ends of the wires together and twist them clockwise. Ensure that the connection is tight and secure. Thirdly, apply a wire nut. Screw a wire nut of the appropriate size onto the twisted wires, twisting it clockwise until it is snug. The wire nut should completely cover the exposed conductors. Fourthly, tape the connection. Although not always required for low-voltage splices, wrapping the connection with electrical tape can provide an extra layer of insulation and protection. Now let's dive into the materials you can use. Firstly, wire nuts. These are the most common and convenient way to splice low-voltage wires. Choose wire nuts that are specifically rated for the gauge and number of wires you are connecting. Secondly, butt connectors. These are crimp-on connectors that provide a secure and reliable connection. They are often used for splicing wires in automotive and other low-voltage applications. Thirdly, electrical tape. Use high-quality electrical tape to insulate and protect the splice. The tape should be rated for the voltage and temperature of the application. Fourthly, junction boxes. Although not required for inaccessible low-voltage splices, junction boxes can provide an extra layer of protection and organization. If you choose to use a junction box, make sure it is properly sized for the number of splices and wires it will contain. Finally, here are the best practices that you should follow for low-voltage wiring. Firstly, always to energize the circuit before working on any electrical connections. This will prevent electrical shock. Secondly, use the correct tools for the job. Using the correct tools will ensure that the splices are made properly and safely. Thirdly, follow the manufacturer's instructions for all materials and components. This will ensure that the installation is done correctly and that the materials are used safely. Fourthly, label the wires. Labeling the wires will make it easier to identify them in the future. It is always good practice to label any wires that are spliced or moved for future reference. Finally, inspect the work. Inspect the work to ensure that all connections are tight and secure and that all materials are properly installed. Now, let's consider the specific requirements for doorbell transformer wiring, particularly when concealing splices behind drywall. Here are the things you should be aware of. Firstly, low voltage nature of doorbell circuits. Doorbell transformers typically operate at 16 to 24 volts alternating current, which is considered low voltage under the NEC. This low voltage reduces the risk of electrical shock and fire, making it easier to meet the code requirements for concealed splices. Secondly, NEC Class 2 and Class 3 circuits. Doorbell circuits often fall under Class 2 or Class 3 classifications, which are specifically addressed in NEC Article 725. These classifications involve power limitations that allow for more flexible wiring methods. Thirdly, exception for inaccessible splices. The NEC recognizes that low-voltage circuits pose a lower risk, allowing for splices to be concealed without a junction box under certain conditions. This exception acknowledges the practical challenges of accessing these low-voltage connections in residential setting. Let's now talk about how to properly prepare and make the splice for your doorbell. Firstly, ensure the power is off. Always to energize the doorbell circuit by turning off the breaker that supplies power to the transformer. Use a non-contact voltage tester to confirm that the wires are not live before proceeding. Secondly, strip the wires carefully. Use a wire stripper to remove approximately 0.5 inches of insulation from the ends of the wires. Be careful not to nick or damage the conductors, as this can weaken the connection. Thirdly, twist the wires together tightly. Hold the stripped ends of the wires together and twist them clockwise to create a secure mechanical connection. Ensure that the twisted wires are tightly intertwined for good electrical contact. Fourthly, use appropriate wire connectors. Choose wire connectors, such as wire nuts, that are specifically designed for the gauge and number of wires you are connecting. Ensure that the wire connectors are approved for the purpose and rated for low voltage applications. Fifthly, secure the wire connectors properly. Screw the wire connectors onto the twisted wires, twisting them clockwise until they are snug. The wire connectors should completely cover the exposed conductors and provide a secure insulated connection. Let's dive into some additional protective measures you can take. Firstly, wrap the splices with electrical tape. Although not always required by code for low voltage splices, wrapping the connection with electrical tape can provide an extra layer of insulation and protection against moisture and corrosion. Secondly, secure the wires to prevent movement. Use cable ties or other fasteners to secure the spliced wires to a nearby structural element, such as a stud or joist. This will prevent the wires from being pulled or damaged, which could compromise the connection. Thirdly, label the wires for future reference. Use a permanent marker to label the wires with their function or circuit number. This will make it easier to identify the wires in the future if you need to make any changes or repairs. And finally, document the location of the splice. Make a note of the location of the splice, such as on a wiring diagram or in a notebook. This will help you or others find the splice in the future if it needs to be accessed. Now let's discuss some common mistakes to avoid when splicing low voltage wires. Firstly, using the wrong size wire connectors. Using wire connectors that are too small or too large for the gauge and number of wires being connected can result in a loose or insecure connection. Secondly, failing to twist the wires together tightly. If the wires are not twisted together tightly, the connection may not be electrically sound, which could lead to overheating or failure. Thirdly, overstripping the wires. Stripping too much insulation from the wires can expose too much of the conductor, increasing the risk of short circuits. Fourthly, using damaged or corroded wires. Using wires that are damaged or corroded can compromise the integrity of the connection and increase the risk of failure. Replace any damaged or corroded wires before making the splice. Fifthly, neglecting to energize the circuit. Working on live electrical circuits can result in electrical shock or electrocution. Always de-energize the circuit before making any splices or connections. A good practice would be to consult local codes and regulations. While the NEC provides a general framework for electrical safety, local codes and regulations may have additional requirements or restrictions. Consult with your local building department or a qualified electrician to ensure that your wiring practices comply with all applicable codes and regulations. By following these guidelines and recommendations, it is possible to safely and legally splice low-voltage doorbell transformer wires behind drywall, ensuring the integrity and reliability of the electrical system while complying with the NEC and local codes. And to summarize, the NEC allows for splicing of low-voltage wires such as those connected to a doorbell transformer and concealing the splice without a junction box. This is because they run at less than 50 volts. The doorbell transformer usually runs at between 16 and 24 volts alternating current and pose a low risk of fire or electrical shock. This falls under the NEC Class 2 and Class 3 circuits. It is important to twist the wires tightly together and use the correctly sized wire nuts for the American wire gauge or auger of the wire being spliced to ensure a tight connection and help prevent issues. As well, secure the wires after splicing so that they cannot move and potentially undo the connection by pulling or other movement. Always be certain to switch off the breaker that supplies the wires before doing any work on them to avoid electrical shock. You can use a non-contact voltage tester to ensure that the wires are not live. When stripping the wires, do not nick the wire as it will weaken the connection. You can wrap the splice with electrical tape for an extra layer of protection. You can also label the wires to make it easier to identify them in the future.